Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient, it'll just be the one I come up with first. So this problem is number 178 on the site, and this is a little bit different from my usual videos. Instead of doing Kotlin, I'm going to be doing a SQL problem. So I'm doing MS SQL because that's what I use at work. And so let's take a look at this problem. This is rank scores. It's a medium difficulty one. So you have a table called scores, and it has an ID and score. They're ints and decimals. And then ID is the primary key. Each row of the table contains the score of a game. Okay. Score is a floating point value with 2 decimal places. Write a SQL query to rank these scores. The ranking should be calculated according to the following rules. The scores should be ranked from highest to lowest. If there's a tie, both should have the same ranking. After a tie, the next ranking number should be the next consecutive integer value. In other words, there should be no holes between ranks. Return the result table ordered by score in descending order. And this is an example. So you have this table where they're given these values, and it returns this. Okay. So you got score, I see. So let's try. So we're going to select first, we want the ID. I space this out a little bit, ID, and then I believe what we want to use is dense rank to get this rank ordering properly. So let's do dense rank over order by score, descending as rank. Oh wait, I gotta do the from statement. Scores from, what's the table called? Scores. Just want to see here. So they expect the score. Okay. So that works for the example. Let's do a submit. All right, easy question. So apparently there are faster methods, which is interesting. I'd be curious to see what the faster method is. I wonder if it's faster to, instead of using dense rank, to do something manual. That'd be kind of weird, because obviously you're kind of meant to use dense rank. But I didn't use any RAM, so that's fantastic. All right, so just going over this really quickly. This one's pretty simple. Let's go back to the description here. So we have this scores table that has an ID and score columns. And simply all we're doing is selecting the score column, and then in order to implement these rules, we're using dense rank. So dense rank specifically ranks all the values and applies this after a tie. The ranking number, the next number doesn't skip any numbers. If you use rank instead of dense rank, then it'll skip values. So like if there was a tie for first place, you'd have 1, 1, and then 3, but dense rank uses this rule, so it does 1, 1, and 2. We're not using, with dense rank, you could also partition it over some values. Like if we had, like, let's say there was another column here that had like category, and you wanted to perform this ranking over separate categories. So like if something was category 1, you'd want to have a ranking between like 1 and 5, but then you also want to have a category 2 where that has a separate ranking from 1 to 5. Then you could partition over that column, but we don't need that in this case. So all we're doing is ordering by score descending and using alias as rank for the column name for that. So that's it. Hope that helped you guys out. Thanks for watching. Catch you guys next time.